All right, so here we go. The word kinematics. The word kinematics means the study of bodies in motion. Like I said, for an example, let's say you're jumping out of an airplane. You need to know exactly how much time to jump out of the airplane, how fast the airplane is, and you need to know how high the airplane is. You need to know some basic measurements. It says here, though, it is a way to combine two or more of the equations. And what equations am I talking about? I'm talking about the equations on Unit 1. Displacement, delta x equals x sub f minus x sub I. Velocity, which is d over t. And deceleration, which is final velocity minus initial velocity divided by time. So, using the basic equations we've already used, we are going to go ahead and combine them into what I call the Superhero Power Ranger morph equations. We already know that D stands for distance or displacement, which we prefer to be in meters. VI is initial velocity, which we prefer to be meters per second. VF is final velocity, again, meters per second. T is time, seconds. A is acceleration, which means speed up, slow down, or change direction. We prefer it to be in meters per second squared, but the problem is when we get to this unit, students start like getting upset and mad because Miss Munson, they didn't give me enough numbers. Yes, they did. The problem is in physics, words have number values. So for an example, if we start from rest, you don't have to give me the number of 0 because from rest, that means that your velocity was 0. And if you're coming to a stop, you don't have to give me the number 0 because I know that you're going to end up at a 0 velocity. But wait a minute, how about this one? Let's see who's smart enough to get this one. Constant velocity. In our notes, we said, I've got to pull out our old notes, but in our notes, we said this business. Right here. We said that acceleration or constant acceleration occurs when an object changes its velocity by the same amount for each second. Please do not confuse this for constant velocity because constant acceleration, which we are going to take a test this Friday, and this is Unit 1, so we need to know this. Constant acceleration is completely a different word than constant velocity. They are completely not the same thing. Let's go ahead and take a glance at Unit 1 notes. This chart, our velocity was changing differently. Yeah, accelerating. The one in the middle, I changed my velocity by 4, 0, 4, 8, 12, 16. Was I accelerating? Yes, I was at constant acceleration and I was moving. The last chart here, 2, 2, 2, 2, 2, 2. I asked you in class last week on Friday, hey, is my object moving? And y'all told me, yeah, it's moving, Miss Munson. The velocity is 2. But yes, it's moving, but it has 0 acceleration. It's not accelerating. Its acceleration is literally 0. So back to our notes. Constant velocity means that there is no acceleration. So I shouldn't have to tell you from here on out because you know now that constant velocity means yes, my object is moving, but no, it's not accelerating, and its acceleration is 0. Here are our 3 equations we've already talked about from Unit 1. Here are our new equations. These equations are called, I call them the Superhero Power Ranger morphed equations. What? It's like we've genetically modified these to come up with the new ones. Here's one of the new equations. A equals final velocity squared minus initial velocity squared over 2D. You do not have to memorize it. It is on your formula chart. The next one, which is a superhero Power Ranger morphed equation, is distance equals initial velocity times time plus 1/2 AT squared. Okay? That's actually the one that we go to almost always. That is the one that we're going to use. If you're jumping out of an airplane to parachute, that's your go-to equation. You better be able to do your kinematics. And then the last one, which it's not used too often, but distance equals final velocity times t minus 1/2 AT squared. Hint, hint, is just like the one above it. Now, I kind of agree with Carlos. This is kind of hard, and this is a lot of information to know, Ms. Munson. So you're telling me that I've got to, in my mind, look at all of these new equations, and number one, I have to identify the variable. Yeah, you got to do that. Identify the variables that are given. Then after that, you've got to be able to choose the correct equation and then solve for that. Well, Ms. Munson, that's kind of difficult. The problem is not only that, but sometimes they're two-step problems, and you might have to use 2 or more equations just to come up with the right answer. So yeah, we're taking it up a notch. Okay, so over here, we've got what I call the easy cheesy equations. That's unit 1, speed, velocity, acceleration. Those are easy cheesy. Ms. Munson, I am confused. Well, guess what? I've got a flow chart for you. When you get a little confused, this flow chart is going to help you. For an example, I don't know which equation to pick, Ms. Munson, and they look kind of difficult. Ask yourself first, number 1, was distance or displacement ever used in the equation? Okay? If you'd say, no, they never gave me distance or displacement, then I guarantee you it is the easy cheesy acceleration equation. Done. If you say, yeah, they did give me distance, yes, then you got to ask yourself the second thing, number 2 question. Was t or time ever used? If you say no, they never gave me time, then in that situation, they did give you VI and VF. Your equation says A equals VF squared minus VI squared over 2D. If you say, yeah, they did give me time, then in that situation, you need to find out, were you given a VI? If so, then your equation is D equals VI times T plus 1/2 AT squared. If they only give you the VF, then in that situation, you're going to use this equation, and I'm going to highlight it. Now, the formula chart is given to you. There are about 3 or 4 equations that are not on the formula chart. I will always tell you, and I will always highlight them. This highlighted one is a memorized. It was on the previous first page. D equals VF times T minus 1/2 AT squared. Okay? This one is on the formula chart, the one above it. This one is not on the formula chart, but don't worry, because this one's on there. All you have to do is swap out the VF for the VI and change the addition to subtraction. It is a memorized one, but look how similar they are. You'll be okay. Turn the page, we're going to do one practice problem, and then we have our last thing to do for the day. Okay? Almost. No, I wish.
The quiz?
I don't know yet. Question number 2. Sounds like you're being negative.
I'm not being negative.
Oh, okay. Because I'm not ready to be negative right now. Here we go. This is the problems that we're going to get to. It says here that a person is pushing a stroller from start. From start is VI of 0. Uniformly accelerating, or a constant acceleration of 0.5 meters per second square. What is the person's or the stroller's final velocity after the stroller moved a distance of 4.75 meters? Okay, we've got to get to this. What do? I go to my flow chart. Was distance ever used, talked about, or discussed? I see Tristan shaking his head. Yes. Was time ever talked about, discussed, or given? No. Now, I apologize because I should have stopped and did something first. To help us with their kinematics, I like to always write out all of my variables on the side. That way it helps me with my flow chart. Distance is 4.75. A was 0.5. T, he was shaking his head, was not given to me at all. VF is my question, and VI was given to me. When I label my variables from here on out, because we use this a lot, I put an X on what they did not give me. I question mark what I'm looking for, because it's going to become a little bit harder next week with our notes. Alrighty? Oh, good. So I agree. The question, or I saw the head shake. No, time was not given to me. That means my flow chart says this is my equation. So let's write that in. A equals VS squared minus VI squared over 2D. What you're going to do is now you're going to fill in your variables. 0.5 equals VF squared minus 0 squared over 2 times 4.75. Oh, man. And then you're going to go ahead and plug it in. But this is where we're pausing, because I figured out a long time ago that my students come to me and they forget about something. They start plugging it into the calculator and they get it wrong, like every time. And they're telling me, Miss Munson, why am I getting this wrong? Well,